Right, welcome back to the advent of Fortran. This is day 8. I will admit that I've already read the prompt for day 8 off screen. I wasn't going to make a video for this, but I decided that day 8 is not as hard as day 7 was. So hopefully it's not that bad. This is the test input. Basically, we have another matrix, another rank 2 array, kind of like day 5, where we had the stacks of crates. And this time they represent the heights of trees in a forest. I'm not going to spend time reading this because I already read it off screen. And we have to figure out which trees are visible from outside of the grid. So that means which trees are higher than everything between them and at least one edge. So everything on the edge is visible, and then 5 is visible because 3 is shorter than it, so it's visible from below. And which one is not visible? I think 3 in the middle is not visible because it's blocked from all directions. It's blocked on the right by a tree which is the same size as it, and it's blocked on all other sides by trees that are taller than it. Right. So this is the test input, and then I also need the actual input. Save this in day 8. And let's see what the real input is like. That's pretty big. So what's the size of this? This is 99 by 99. So every grid is square. That makes it easy. I can dynamically get the width of the first row and then just assume that the number of rows is the same as the width of the first row. That'll make it easier to dynamically allocate things. I could just hard code it, but it's not too hard to dynamically allocate for this case, so I'll go ahead and do it that way. So this is going to be the size of the grid in the x and y dimensions. The x dimension is going to be horizontal and y is going to be vertical, as you would expect. I haven't decided. X is going to be positive from left to right. I haven't decided which direction is going to be the positive y direction. I might index it from the top down, or maybe I'll go bottom up. I'm not really sure yet. So we have the size of the grid, and then we have the grid itself, which I'm going to make an integer array. And these are all global variables. I'll call this A, because A is a standard name for a matrix or a rank 2 array. So I'm going to have some variables to index in both directions. Call this ix and iy. Initialize those, and then when we read the first row, I'm going to allocate the grid. So every time I read a line, I'm going to increment ix, or no, iy, because every row is a new y value. So I think I'll index from the top down in the Y direction because that's the order that I'm going to read the grid. And then if it's the first row, I need to count and allocate the grid. So I will allocate here, and X is going to be the length. This is 99, so my line size 256 will work. And I'll initialize everything at 0 just to be safe. Some of these are actually 0. So actually I'll initialize it to -1 instead. So that's the allocation in the first row, and now I need to read each number into the grid. So we'll read it row by row. This do loop will loop through the Y values, and within one row I need to loop through each X value, column by column. I will read from the string, from index IX. The prompt says that these are all one-digit numbers, so they're going to be 0 through 9. You don't have to do anything special for 2-digit characters because there won't be anything greater than 9. So that should read everything, and then I can print this to make sure that I read it correctly. I'll do this with a loop so that I don't have to do any tricky string formatting. This will be a 1 character wide integer because that's guaranteed. And then at the end of each row, I'm going to print a new line. But after each character, I want to suppress the default new line output, and you do that in Fortran with advance equals no. And then at the end of the row, that will write a new line. So this should just print out my grid. I want to do the test data. And there it is. Looks like I read that correctly. So now I get to solve the actual problem, which is counting the number of trees that are visible. You know what? These really don't need to be global variables. And then I can have a subroutine, or better yet, a function that counts the number of visible trees. And then I'll have copies of these local variables, and these will be dynamically determined from the input. Because A is nx by ny, so nx is the first dimension and ny is the second dimension. So these are consistent. Just want to make sure that that is determined correctly. It never returned. Yeah, I don't have a type. Okay, so the sizes are correct. Now I have to count. So that's going to be another nested loop. And inside here, I have to determine if the tree at position ix, iy is visible from any direction. So it could be visible from the left, from the right, from above, or from below. And I decided that day 8 is easy when I was reading this prompt because it's an array-oriented problem, and Fortran is an array-oriented language. So Fortran is perfectly suited to this problem. We just need some array operations. And yesterday I used the any function right here. So this compares a character to an array. And when we use this comparison operator, this creates a Boolean array. And then if any one of the Booleans or logical values in that array is true, then any of that array is true. So Fortran has these two functions called any and all. MATLAB also has those. So those make it very easy to figure out if a tree is visible. So if it's visible from the left, I'm going to make a temporary variable called tree. That way I don't have to type as much in all these subsequent conditions. So I'll use all instead of any, because all of the trees to the left of the current tree have to be shorter than the current tree for the tree to be visible from the left. So if all trees to the left, and that's going to be 1 through ix minus 1 in the same row, iy, they all have to be less than the current tree height. So if that's the case, then we increment the count and we cycle. So what cycle does is it advances to the next iteration of this inner loop. Because if it's visible from the left and from the right, I only want to increment the count. And I forgot to increment it. I only want to increment the count once, because it only matters if it's visible, not how many directions it's visible from. So that's the left, and then I need to check if it's visible from the right. And that will be ix plus 1 through nx. And then we have to do the same things for above and below. Or north maybe we can call this west, east, north, and south. So north is up, and the array A is indexed from north to south. So instead of left, let's say west and east, because I don't want to say up and down. Up and down doesn't make sense for a map. North and south makes more sense. So this will be ix, and this will be 1 through iy minus 1. We don't want to compare the tree to itself. That's why it's iy minus 1 and plus 1, similarly in the other direction. So this is going to be iy plus 1 through ny. And I think that's it. So the answer that I expect for the test input is 21 trees visible. Oh. So the other special case is that trees on the edge are always visible. And I think that should happen automatically. I don't think I need to add any extra logic for that. And that's 21, that's the answer I expected. And now I have to run that on the big data. So it says 17988. I don't need to be printing. I don't need to be printing everything. So I'll comment that out, but it's 17988. Why is it still printing? It's printing here as well. And I think that's it. It's all Gucci. Let's check out part 2. Bear with me while I awkwardly read this part in silence, because I read part 1 ahead of time, but I haven't read part 2 yet. Okay. That sounds not super difficult. A little more intricate than part 1, I guess, but nowhere near as hard as day 7. So I'm copying and pasting the reading part. I'm not going to bother refactoring that. And now I want a function that gets the scenic score. Actually, I want a function that gets the max scenic score. So the body is going to be similar as the body of the count visible function. I'll initialize that to -1. Just updating these comments because these are scores now. It's not just a logical distance. And I need to save these and multiply all of them. So we have the score from the west, score from the east, north, and south. So those are 4 numbers that I'll get in this body. I won't be cycling because I need all 4. And then the score for this tree is the product of all of the directional scores. And we want the max overall. So I still need to fill in this body, but I'm just doing the higher level logic. And this is going to accumulate the max of all of the individual tree scores in this. And once the loop finishes, that will return the answer for part 2. And I need to call that function. And finally, I need to fill in the body for this part. And there's not going to be logic like that. So we have to get the viewing distances. So for this tree, the edge case is a little bit weird because it's 2 to the left, or no, it's 1 to the left. Looking up or north, they're saying up, which doesn't make sense because it's a map. Up is out of the map. Really, it should be north. So I call it north in my code, but it's the same thing. So the edge case is weird. It's 1 to the north, even though you can kind of see infinitely far because you get to the edge of the map, but they call that 1. So and it could be 0. So we're going to do while a score from the west. It's going to be ix minus sw minus 1. In some of the other directions, that's going to be a +1 instead of a -1. In the same column, the same height or taller. So do while this tree is shorter than the current tree. Increment +1. This is getting subtracted, so I'm adding to SW to go to the west. I think that's right because I'm about to copy this 4 times. SW to the east. This is going to be SE instead of SW. And then this is going to be IX plus SE plus 1. Oh, and I forgot the edge case. And the edge case, it's going to be easy to make this off by 1. IX minus SW is greater than 1. Because that means this is going to be when this is greater than 1, that means this is 2. So this will be 1. And then we'll add 1 more. No. So I think I need to check this is greater than 1. So this will be 1. And it adds 1 more, so no, I don't think that's right. That means this will be 2, this will be 2, then we'll add 1, and this will become 1. Yeah, so I think this should detect the edge case correctly. So delete that, copy it again, replace the SWs with SEs. And now we're going east, so we're adding, and this has to be less than NX. And now I need to do north and south, which is the same thing, but with the other index of the array. So SW, now I'm replacing it with SN for the north distance, the north viewing distance. Y. This one is the same. Then it's easier to copy east for south. Now I'm replacing SE with SS. And these pluses, yeah, the pluses are still pluses, but now I'm swapping the first index with the second index. So, oh, made a mistake there. This should be IY. And this should be IY. Less than NY. I think that's it. So let's see what the max scenic score is. So for the test input, it should be 8. And I'm overflowing the array bound. Maybe I need to put the edge case condition in here. Now it's probably going to crash in one of the subsequent loops now, but I just hope that this won't crash at line 91 anymore. Nope. It's the very first one. Okay, so trees on the edge. Trees on the edge will always have a scenic score of 0. So I don't need to loop through those ones. I only need to loop through interior trees. 21. Oh, part 1 is 21. That's not right. Is that necessary? I don't need to do it like that. I can just make these integers shorter. There's 6 of them. What are you talking about? So position, position. This is a table of the positions and then the viewing distances in all 4 directions. So they have a couple of examples here that we can focus in on. So for position, ix equals 2 and iy equals 2. So that's this one. Do I have my comparisons wrong? Should this be greater than or equal? Because wait, no, 2, 3. This is the one that I'm looking at. This is the one that's highlighted. Looking up, when they say up, that's north. So they're saying, I'm saying 0 and they're saying 1. So the edge case is wrong. Line 91. It's the same thing. 0, 2, 0, 1. And it's still saying 0, 2, 0, 1. West. From the left, looking left, I can only see one tree. Yeah, so if a tree is on the edge, one of its viewing distances is 0, and then the product is guaranteed to be 0. So that's why I only need to loop through these ranges. So that part's okay. But I think I need to initialize these at 1, not 0. Because when we look to the left from here, they're saying this counts as 1, and I'm saying it counts as 0. So I'm initializing this wrong. It should be 1 instead of 0. And then that means I don't need to subtract another one here. Yeah, so that should be my stopping condition. I shouldn't add an extra one there. And then do I need that extra exit? Okay, now it's saying 1 to the left, 1. So that one is right. Now I need to fix the other 4 cases. There's a way that you can do this without having 4 cases. You could have a general function which adds a distance to the current position by adding a vector. Like this direction would be -1, 0 to go west. And then you could set 4 different directions and use a shared function that adds a distance and checks. But I think I'm close enough to the finish line that I might as well do it like this. And this exit condition, if I'm exiting here, then I don't need to have it in the body of the while condition. So I think that should be okay to the west. And it runs without crashing, so yeah, I think that's okay. Now I need to copy this 4 times. And this is wrong. So W's are east now. And we're adding. And if this is the right edge, exit. That didn't work. There we go. Just needed a looser condition there. From the north. Okay, and then south. All of the minuses turn into pluses. That's NY. So I think that should be it. Not quite. Greater than 24. Are my edge cases wrong? Yep, so I think the edge cases are wrong. So this tree is 2212. Wait, that's the wrong tree. This tree is 1122. Which one? Looking right, its view is not blocked. So to the east. East is wrong for this tree. Three. Okay. There should be a way to do this without writing so many lines of code. But it is what it is. Eight. so this is tree 3, 4. Edge cases are still wrong. So the self is incorrect. I can see 1 tree. That doesn't make any sense. South, 2 of these are wrong. Looking up, I can see 2 trees. That's correct. Looking left, I can see 2 trees. If that one wrong. It's west. Was this totally unnecessary? Okay. Okay, a lot of that was unnecessary. I'm gonna clean up this code. And then this can be 1-line ifs again. Didn't I do this? Like, didn't I already run code that looked exactly like this? I thought so. I guess not. And 8. So I think that's it. Let's try it on the actual data. The big data. And let's hope that everything's Gucci. Is this the right answer? That took a little bit longer than I hoped it would, but still nowhere near as bad as day 7. I'll commit that and push it. I can clean up a lot of these prints. That might be the only one I have to clean up. Yeah. I don't care about that either. So I think that's it. Is that still giving me the same answer? Yeah. Alright, I cleaned it up without breaking anything. Now I just need to add this and commit it. I just put a separator in utils off screen, nothing major there. And I will confirm that that pushed day 8. There it is. So that's it for today. I'll catch you next time.